Now this is chapter 5, complex numbers and quadratic equations. In the previous classes, what we have studied is we have studied about the linear equations in one variable. We have also seen the quadratic equations in one variable. And we also have seen this kind of expression like x square plus 1 equal to 0. What it means is this is actually equal to x square equal to minus 1. And where it came, because the square of every real number is always non-negative. You say minus 2, square it, you'll get 4. Any negative number you take and you square it, you'll get always this number. So the square of every real number is non-negative. How you are going to solve this? Because you are saying that it has no real solution in the previous classes. But now let us extend our discussion and we will now concentrate upon the solution of x square equal to minus 1. In fact, what we'll do, whenever we come across this kind of equation and b square minus 4ac, when it was equal to 0 or greater than 0, we didn't have to worry about. But when it was less than 0, we said, okay, this is not going to have any solution because the root was containing the negative number, some negative x. So we just thought that, okay, it is not possible to solve it. Let us forget it. But now we will concentrate on this only. And this is called as complex numbers. How complex numbers? Because we have just seen that x square equal to minus 1. Let us now formalize it. Let us denote this root minus, because actually what is happening? X is equal to minus 1 and the root minus 1. So this root minus 1, let us give it a symbol called I. And this I, you square it both sides. So you will get I square is equal to 1 minus 1. So I square is equal to minus 1 and I is equal to under root minus 1. So these two you get. 1, 2. So this is going to mean that I is the solution of x square plus 1 equal to 0. So the number which is of this form a plus ib, where a is going to be a real number, b is going to be a real number. This form, any form of this type a and b where real number I, as we just defined, a plus ib is called the complex number. For instance, these 2 plus i3, like these are complex number. Here a is minus 1, b is root 3, a is 4, b is minus 1 by 11. So for the complex number which is given by, which we will use as z, small z, which is equal to a plus ib, a is the real part, r is z, we write it. B is the imaginary part, we write it I am z. So these are the imaginary and complex part of z. For instance, if z is equal to 2 plus I into 5, then this 2 is the real part of z and 5 is the imaginary part of z. And the complex number, these two complex numbers, when are they equal? They are only equal when the corresponding value, real part a is equal to c and the imaginary part b equal to d. Imaginary part has to be equal and imaginary part has to be equal. Let us take an example. 4x is equal to I 3x minus y, 3 is equal to I minus x. If they are equal, that means 4 has to be equal to 3, which we wrote 4x, sorry. And 3x minus y has to be equal to minus 6. 3x minus y we wrote as minus 6. So these two are equal. So from this equation we get x equal to 3 by 4. We replace x to 3 by 4 and we get y. Y is 33 by 4. This is how we get x and y. What about the algebra of complex numbers? As we have seen about the algebra of normal numbers, algebra of complex number is also possible. So what we are going to see there in the algebra of complex numbers is first the addition of two numbers. If z1 is a plus ib, z2 is c plus id, if you add them, you have to add the real parts and you have to add the imaginary parts. Means this will be a plus c, I, b plus d. So this is how we added real part and imaginary part. And this also you can add 2 to minus 6 and 3 to 5 like this. So it will be minus 4 plus I8. We have certain properties which this addition of complex number satisfies. First is the closure property or closure law. Closure law is when you add z1 and z2, these two complex numbers, the answer or the result will be going to be a complex number. Second is the commutative law. Means if you add z1 with z2, then if you add z2 with z1 also, it is going to give you the same result. Then we come to the associative law. This associative law means if you have three z1, z2, z3 as complex numbers, you add z1 with z2 and then add z3, or you add z2 and z3 then add with z1. These two are going to be same. What about additive identity? Additive identity means if you have say some number 2, you add with 0, you get 2. So 0 is the additive identity of 2. In the same case, for complex number also we have identity 0, but it is written as 0 plus I 0, which is denoted by 0 again. So the additive identity, or you can say the 0 complex number, exists for every number. So you add this z, as we added 2 with 0, you add this z complex number with 0, you always get the same number, that is z. What about the existence of additive inverse? For every complex number, z is equal to a plus ib. We have the complex number minus a plus I minus b. That means if we have any number, say 2, you have additive inverse, that is minus 2, so that you can get the additive identity, or 0. So 2 minus 2 is 0. So minus 2 is the additive identity of, or additive inverse of 2. So for a plus ib, you have minus a minus ib. So this is the additive inverse of this. So z, if it is your complex number, minus z is going to be your additive identity, or the value with which z is added gives you 0, or the additive identity. Then the difference of two complex numbers. Difference of two complex number is nothing but z1 minus z2 is nothing but z1 plus z2. So we have already talked about minus z2. Addition of these. So just add these. If you want to add the real part, add the complex part. So 6 plus 3i minus 2 plus I, that means you add these two. 6 plus minus 2, that is 4, and 3i plus I, that is 4i. And what about these? Real part, imaginary part will give you minus 4 minus 4i. What about multiplication of two complex numbers? When you multiply two complex numbers, if z1 is going to a plus ib, z2 is going to be c plus id, and if you want to multiply it, this is going to be the result. You can memorize it, or I'll tell you how to do it. I'll explain this one. So 3 plus i5 and 2 plus i6. Let us multiply them. 3 with 2, 6. 3 with 6, 6 is 18. So 89 plus 5 plus 2, 10. I, this for the multiply by this, and again this. 5 6 is 30. But I square, I into I is I square. I square is what? I square is minus 1. So we replace with minus. I square is minus 1. So let us take these two values. 6 minus 30 plus I, and these two values, 18 plus 10. What you are going to get? This is minus 24, and this is your 28. There are certain properties also with respect to the multiplication. That is, the first one is the closure law. Closure law means when you multiply z1 with z2, two complex number, if you multiply, you are going to get the complex number. What about the commutative law? Commutative law means if you have two complex numbers z1 and z2, if you multiply z1 with z2, you will get the result z2 into z1. They two are same. z1 with z2 and z2 with z1, they give you same result. What about associative law? When you want to multiply three complex number, or maybe more than that, you multiply z1 with z2 and then result with z3, or z2 with z3 and the result with z1, the value is going to same. So this will be associative law. What about existence of multiplicative identity? Say if you have 2, you multiply it with 1, you get 2. So 1 is the multiplicative identity of 2. In the similar fashion, for z you have 1. What is this 1? 1 plus i0, 1 plus i0. This is the multiplicative identity. What about the multiplicative inverse? If you have z, you ought to have 1 by z. That is, if you have 2, you multiply it with 1 by 2, you get what? 1. So you multiply something with I, with your z or value, you get the multiplicative identity, that is this 1. So this z multiplied by 1 by z is going to give you 1. So this 1 by z, or also written as z inverse, is the multiplicative inverse. We are going to see how this comes. What about the distributive law? Distributive law say this is the distributive over multiplication. z1 into z2 plus z3 means z1 z2 plus z1 z3. Similarly, this gives z1 z3 plus z2 z3. And what about the division of two complex number? You can divide two numbers z1 by z2, but just understand this Z2 cannot be 0. So this Z2 cannot be 0, otherwise everything is fine. Let us take an example, 6 plus 3i and 2 minus I. When I divide these two, that is 6 plus 3i by 2 minus I. So how you can get that? 2 minus I we need to solve actually. So let's multiply by 2 plus I, because we know that this a plus b and a minus b is what? A square minus b square. This is going to give you 2 square minus of I square. And in the numerator you can multiply directly. 6 to the 12 plus 6i plus this 6i plus 6 to the 12, and then 6i again 6i plus 3i square, make it minus 3. Okay, so what you are going to get, 6 plus 6 is 12, 12 plus 12 is 12 and minus 3 divided by 2 square minus I square. What is this 2 square? 4. What is this I square? Minus 1. So minus of minus 1 is 1. So 4 plus 1 is 5. In the denominator you got 5. In the numerator you get 12 plus what? 12i. 12i, and this was 3. 12 minus 3 is what? 9. So let us replace this 12 by 9. So actually you got 9 plus 12i. Let us write 1 by 5 here. 9 plus 12i. This is exactly what we got here. So this was the introduction of complex numbers. We are going to take much more of these in the next discussion. Thank you so much.